In this session, we're going to solve compound inequalities. And compound inequalities usually have an and or an or in them. And remember, we're going to represent, and remember that when we solve inequalities, we're going to solve them. We're going to graph the solutions on a number line, and we're going to express the solution in interval notation. Now, an inequality with the word and will indicate the overlapped portion that is shaded. An inequality with the word or means anything that's shaded at all. For the overlap portion, it's both red and green, and we're only talking about the portion that's in between the two parentheses. That's where the overlap is. In the case of or, we mean to say either the red portion or the green portion that's shaded. Now, and typically makes us think of more things. But in the case of inequalities, and means that there are more conditions to be satisfied. So, suppose you're thinking of a person, and the person has blue eyes, and the person is tall. You kind of have an image of what this person might look like. On the other hand, if I say we're thinking of a person or something with blue eyes or something that's tall, then we could be talking about a tall person with blue eyes, but we could also be talking about a husky. So that's a way to remember the difference between and or. Let's get started. Alright, we start out with this compound inequality, which is 3x plus 1 is greater than 4, and 2x minus 3 is greater than 7. First question I would usually ask a class is, what do these two inequalities have to do with each other? The answer is absolutely nothing. We're going to solve each one individually as we would any inequality. And so for the first one, subtracting 1 from both sides gives me 3x is greater than 3. And then I'm dividing by, oh look, a positive 3, so nothing switches or anything. X is greater than 1. For the other inequality, I'm going to add 3 to both sides, like I normally would, and get 2x is less than 10. Don't forget our and. And finally, dividing by, again, positive 2 in this case. X is less than 5 with an and in between them. Then the and is going to tell us how to interpret what we're looking at on the number line. I'll mark a 0, a 1, and a 5. And x is less than 5 means a parenthesis at 5 opening to the left, shaded to the left. And x is greater than 1 means a parenthesis at 1 opening to the right, shaded to the right. And now we see the and portion. The and means overlap, whatever it's double shaded. So I would want you to express to me that the solution is parenthesis at 1, shaded in between 1 and 5, and a parenthesis at the 5. Interval notation is going to be 1, 5 with parentheses all around, and the inequalities, the graph, and the interval notation constitute the complete solution to this compound inequality. So here I have a compound inequality. Negative 2 is less than negative 3x minus 2 over 4, which is less than or equal to 2. And so we have here a three-way inequality that has two inequality symbols. That's what makes it compound. Now suppose we didn't have the less than or equal to 2 on the right. Let's focus on the negative 2 is less than the negative 3x minus 2 over 4. If I wanted to solve this inequality, I would start by clearing the fractions. I would multiply both sides by 4. Now, let's back up a little bit. And suppose we didn't have the portion on the left. Suppose our inequality was simply negative 3x minus 2 over 4 is less than or equal to 2. I would still start out multiplying both sides by 4. In other words, whatever we do to one part of an inequality, we have to do to all the parts of the inequality. So when I multiply by 4, I'm going to multiply each of the 3 parts by 4 to end up with negative 8 is less than, and in the middle portion the 4's divide out, and I have negative 3x minus 2 is less than or equal to 8. Now I'm going to add 2 to all 3 parts. I almost said both sides, but this is a three-way inequality, so it must be all 3 parts. And I get negative 6 is less than negative 3x, which is less than or equal to 10. Now I'm going to divide, and let's note I'm going to divide by a negative 3. Hopefully we remember that when we divide an inequality by a negative number, the inequality symbol is reversed, but this is kind of self-correcting in this case. Negative 6 divided by negative 3 is 2. On the right-hand side, 10 divided by negative 3 is negative 10/3. In the middle, the negative 3's divide out, leaving me with just x. And let's note that 2 is bigger than the negative 10/3, and so each of the inequality symbols is going to reverse. Notice I don't switch the places of the strict versus non-strict inequality. It's just that each inequality symbol reverses. Now, I'd rather see this from small to big, so I'm going to write it as negative 10/3 is less than or equal to x, which is less than 2. And we see here on a number line that x is between negative 10/3 and 2. I'm going to put a square bracket at negative 10/3 and a parenthesis at 2. We'll shade in between. It's a little clearer to see here than when we use the word and. And the interval notation uses the same symbols that we have on the number line. Square bracket, negative 10/3, comma 2, parentheses. And the solution and the graph and the interval notation constitute my answer to this compound inequality. If you'd like to see another example like this one, you'll find it 17 minutes 36 seconds into this video towards the end. Now we have 7x minus 4 is less than or equal to 10, or 2x minus 3 is greater than 9. Well, I'm going to solve as usual, which means for the first one, I'm going to add 4 to both sides to get 7x is less than or equal to 14, and then dividing by 7 gives me that x is less than or equal to 2. I'm going to keep writing the or, so I know what I have at the end, and in the second inequality I'm going to add 3 to both sides to get 2x is greater than 12, write that or again, and x is greater than 6. So we have x is less than or equal to 2, or x is greater than 6. Let's see what that looks like on a number line. I'll put a 0 for orientation, and then a 2, and then a 6. And if x is greater than 6, I'm going to put a parenthesis opening to the right, and x is less than or equal to 2, so I'm going to put a square bracket opening to the left. I'll shade accordingly, and I see that I have 2 distinct intervals from negative infinity to 2 with a square bracket at 2, and then from 6 to infinity with a parenthesis at 6. And remember, the infinities always get parentheses, and because I have 2 distinct intervals, I'm going to join them with a union symbol. And I have the solution, the graph, and the interval notation. In this next compound inequality, we've got negative 3x is less than 9, or 3 minus x is greater than negative 8. So I'm going to divide both sides by negative 3 for this first inequality, and since I'm dividing by a negative, my answer is negative 3, but the inequality symbol, which had been less than, is going to reverse and become greater than. For the other inequality, when I subtract 3 from both sides, I get negative x is greater than negative 11. So I'm going to write or and finish solving the inequality by multiplying by a negative 1. Since I'm multiplying the inequality by a -1, the inequality symbol, which had been greater than, is now less than. So I have x is less than 11, so I'm going to mark 11 on the number line. At 11, I'll put a parenthesis that opens to the left and shade to the left. For the other inequality, I have x is greater than -3, so I'll mark -3 on the number line and open a parenthesis to the right, shade to the right, and here we're looking at OR. This was an OR inequality. Remember, OR means anything that's shaded. Notice the entire number line is shaded. The solution to this is all real numbers, which I'll indicate using the blackboard bold R. For interval notation, I'll say -infinity to infinity with parentheses all around. This is the solution to the inequality. Here we have 4x plus 5 is greater than 13, and 3x minus 2 is greater than 16. So solving this inequality means I'm going to subtract 5 from both sides, so 4x is greater than 8, and x is greater than 2. We'll write the word AND because that's what we were looking at. And for the second inequality, when I add 2 to both sides, I have 3x is greater than 18, so x is greater than 6. Now here we have our number line, and if x is greater than 6, well, I'll put a 6 on the number line, parenthesis opening to the right, shading to the right. Let me label the number line x. If x is greater than 2, then I'll mark 2 on the number line, and I have a parenthesis that's, oh my gosh, also opening to the right. Let's remember that AND means overlap. To the left of 2, there's nothing shaded. In between 2 and 6, I have one piece of shading for the part that was greater than 2. But remember, AND means we have to satisfy both conditions at the same time. So the portion between 2 and 6 doesn't work, and only the portion from 6 to infinity satisfies the AND inequality. So the interval notation is going to be 6 to infinity with parentheses all around. Now, suppose this inequality was a little bit different to begin with. Suppose instead of starting out with an AND, we had started out with an OR. Well, solving each of these inequalities would have been the same. So we still would have had x is greater than 2, and we still would have had x is greater than 6, but there'd be an OR between them. So the graph on the number line would look the same. We'd have a parenthesis opening to the right at 2, a parenthesis opening to the right at 6. We'd shade to the right for both of them, but remember, OR means anything that's shaded. Again, the portion to the left of 2, nothing is shaded at all. But when we talk about OR, we're referring to anything at all that is shaded on the entire number line. And so our interval notation here is going to be from 2 to infinity. And that's a good way to see the difference between AND, which is the overlap, and OR, which is anything at all that's shaded. Let me put this a slightly different way. For the AND inequality, we want numbers that are greater than 2 and greater than 6 at the same time. Well, greater than 2 and greater than 6 means you're greater than 6. For the OR inequality, we want numbers that are greater than 2 or greater than 6. And if you're greater than 2 or you're greater than 6, well, you're greater than 2. Here we have another compound inequality. 1 minus 3 halves x is less than or equal to 4, and 1/4 x minus 2 is less than -3. When I subtract 1 from both sides of the first inequality, I have -3 halves x is less than or equal to 3. And here I'm going to divide by -3 halves, which looks a whole lot like multiplying by negative 2/3, and hopefully a little red flag went off in your head. We're multiplying by a negative. On the left-hand side, the coefficient divides out, and I have x. On the right-hand side, the 3's divide out, and I have negative 2. But since we divided by a negative, the inequality symbol reverses. Let's finish up the other one. And when I add 2 to both sides, I have 1/4 x is less than negative 1. And then when I multiply both sides by 4, nothing switches around. We're multiplying by a positive, and so x is less than negative 4. The graph will look like a square bracket at negative 2 opening to the right, because x is greater than or equal to negative 2, and parentheses opening to the left at negative 4 with shading to the left, because x is less than negative 4. Remember what and means. And means overlap. Folks, if I'm shading to the right of negative 2 and to the left of negative 4, there is no overlap. And if there's no overlap, then there's no solution. That's what I would put as the answer to this inequality. Finally, we have 2x minus 6 over 3 is greater than or equal to 2, or 3x plus 8 over 2 is less than or equal to 19. To solve the first inequality, I'm going to clear the fraction, and so I have 2x minus 6 is greater than or equal to 6. Adding 6 to both sides, I get 2x is greater than or equal to 12, and so x is greater than or equal to 6. For the other inequality, I have 3x plus 8 is less than or equal to 38. I almost forgot my or. Subtracting 8 from both sides gives 3x is less than or equal to 30. And then finally, notice I keep writing or. X is less than or equal to 10. Let's go for graphing on the number line. For x is greater than or equal to 6, I have a square bracket at 6, opening to the right, shading to the right. And for x is less than or equal to 10, I have a square bracket at 10, opening to the left, with shading to the left. And remember, this was or. Or means anything that's shaded. Since we can see the entire number line is shaded in this case, our interval notation is negative infinity to infinity, which we can also represent using Blackboard Bold R. And here's the last example I have for you, another three-part inequality. 1/6 is less than x over 6 minus 1/4 is less than or equal to 2/3. Since we have fractions all over the place and denominators are 6, 4, and 3, our least common denominator is going to be 12. So we're going to multiply each term in the inequality by 12. Notice we have to multiply all three parts by the least common denominator. So 12 times 1/6, that reduces to 2, is less than 6 into 12 goes 2 times, so I have 2x. 4 into 12 goes 3 times, so minus 3 is less than or equal to 3 divides into 12 4 times, leaving 8. Now I'll add 3 to all three parts. We get 5 is less than 2x, which is less than or equal to 11. Finally, divide by the positive value of 2. And I have 5 halves is less than x, which is less than or equal to 11 halves. And our first thought is, ew, fractions. But calm down, we're not doing anything with them, except graphing them on the number line and using interval notation. So on the number line, we have a parenthesis at 5 halves opening to the right, a square bracket at 11 halves opening to the left, and we're shading in between. And finally, interval notation, parentheses 5 halves, comma, 11 halves with a square bracket, and the inequality, the graph, and the interval notation constitutes the complete answer.